What makes dangling pointers crash apps unexpectedly? Imagine trying to open a door that no longer exists. That's similar to what happens when a program uses a dangling pointer. These pointers are like old addresses pointing to memory that has already been freed or deallocated. When the program tries to access that memory, it causes unpredictable behavior. This is because the memory might have been assigned to other parts of the program or even the operating system. The result? The application can crash suddenly or behave in strange ways. The main reason dangling pointers cause crashes is because of what's called undefined behavior. When a program accesses memory that is no longer valid, it might read garbage data or overwrite important information. This can lead to segmentation faults, which are errors that happen when a program tries to access restricted memory areas. Sometimes, the memory that was freed might be reused by other parts of the program, so the dangling pointer now points to something completely different. If the program writes data to this new location, it can corrupt other data or cause a crash. Another common cause is when a pointer points to a local variable inside a function. Once that function ends, the variable goes out of scope. The pointer still points to that memory, but it's no longer valid. If the program tries to use that pointer later, it can read garbage values or cause a crash. This is often seen in cases where developers forget to set pointers to null after freeing memory. Without doing this, the pointer still points to the old memory location, which might be reused or invalid. Because dangling pointers lead to unpredictable results, they also pose security risks. Attackers can exploit these invalid memory accesses to execute malicious code or cause the program to crash intentionally. Debugging these issues can be tricky because the crashes happen unexpectedly and might not always be reproducible. Using tools like memory profilers and static analyzers can help detect dangling pointers early. Setting pointers to null after freeing memory, avoiding returning pointers to local variables, and using smart pointers in languages like C++ are good practices to prevent these problems. In essence, dangling pointers crash applications unexpectedly because they point to memory that is no longer valid. When the program tries to access or modify that memory, it triggers errors that can cause crashes, data corruption, or security vulnerabilities. Managing memory carefully and using debugging tools can help keep these issues at bay and make your software more stable.